Hey everybody, welcome to 5.3 Inequalities and One Triangle. This video is going to center around this theorem right here, the exterior angle inequality. It's very similar to the exterior angle theorem. You'll recall that the exterior angle theorem said, like, if you're looking at this angle 1 here, it'd say angle 1 is equal to angle A plus angle B, the remote interior angles. So this one says the measure of an exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. In other words, measure of angle 1 is greater than measure of angle A, and measure of angle 1 is also greater than measure of angle B. We don't know anything about angle C. It could be greater than angle C. It could be less than. It could be equal to it. So all you can really assume is that this exterior angle is greater than these two angles because it is equal to the sum of those. That's basically it. So the confusing part about this for kids is determining what an exterior angle is and what a remote interior angle is. So let me zoom in on this picture of this triangle. And so an exterior angle of a triangle is going to be a continuation of a leg of the triangle. So if I were to draw this here and put like a 2 there, this would be an exterior angle. And then if I were to draw this here and put like a 3 there, that would be an exterior angle. But if I were to like erase this and let's say we bent it like that, and then I put a 3 here, angle 3 would not be an exterior angle because it's not a continuation of one of the legs if it like changes directions. I mean, yes, it's exterior of the triangle, but it's not going to have like this angle B and this angle C on the inside. Those aren't going to be its corresponding remote interior angles, okay? So in order to like go with this property, the angle that's like exterior has to be coming from an extended leg, if you will, of the triangle. Now, what it means to be a remote interior angle is it cannot be a linear pair with it or adjacent. That's a better word. It cannot be adjacent to the angle. So a remote angle has to be like a going opposite over it. So it's going to skip over the adjacent angle, and it's gonna be the two angles that are, I guess, kind of across from it. So you jump inside and then go across, and those are your remote interior angles. So I hope that makes sense. If it doesn't, I hope it makes more sense after we do these examples. Okay, so in this figure, I'm going to identify the angles that are less than angle 7 and then the angles that are greater than angle 6. So if we look at it from angle 7's perspective first, angle 7 is an exterior angle of two triangles here. It's going to be an exterior angle of the big triangle, the JKL triangle, and then it's also the exterior angle of the MKL triangle right there. But it's not going to be an exterior angle of, say, the JKM triangle. Okay, so let's look at the small triangle first, the MKL triangle. Angle 7, see, angle 6 is the adjacent angle, so if you were to skip over that, the two opposite on the inside would be 4 and 5. Angle 7 is going to be greater than angle 4 and greater than angle 5. And then if you look at the perspective of the big triangle, angle 7 is going to be greater than this angle here, so it would be the sum of angle 2 and angle 4. So we don't know what that sum is, so you would just say angle 2 as well. We already said angle 4, it's greater than angle 4. And then it's going to be greater than angle 1 as well. So a question kids might have is, why isn't it greater than angle 3? And for all we know, it could be, but we cannot, with this exterior angle theorem, we cannot gather that it's greater than angle 3 without knowing any measurements. And the reason for that is it's not a remote interior angle. Angle 5 is, because it's a remote interior angle of MKL. And then if you look at JKL, the remote interior angles are angle 1 and then the sum of angle 2 and 4. So angle 3 is just stuck somewhere in the middle there. So that's why we don't have enough information, because the exterior angle theorem only talks about the remote interior angles, and this is not considered a remote interior angle because it's not tucked away in one of the corners of the two triangles that angle 7 is associated with. So I hope that makes sense. If we look at angle 6 and we say, what are the angles that are greater than angle 6? The key to that will be identifying what are the exterior angles associated with angle 6. And so what I mean by that is, what triangles is angle 6 in, and what angles are exterior of it. So angle 6 is in this triangle, MKL, and then it's also in the big triangle, JKL, just like angle 7 was associated with those two triangles. So angle 6 is going to be less than angle 7, and because it's a continuation of this KL side, so that's definitely an exterior angle of JKL and MKL. But angle 6 also going to be less than angle 8 because it's an exterior angle of the JKL triangle, because it's a continuation of this JK side. So angle 8 wouldn't be associated with the MKL triangle, because see how it turns from point K if you were to just ignore all this other stuff and just look at the triangle MKL. So, but it does work because it's a continuation of JK, and that is a side of the JKL triangle, which angle 6 is a part of. So I hope that makes sense there. So in this next example, I'm going to identify the angles that are less than angle 1 and greater than angle 8. So the first thing I like to do is identify what triangles are associated with angle 1 and then separately angle 8. But angle 1 is the exterior angle of the PRQ triangle. And I think that's pretty much it, because this right here is clearly not a triangle, all right, which is what it would also be exterior of. But if it's got 4 sides, it's not a triangle. So this SQR triangle is not really going to be related to angle 1 per se. So angle 8 is also on the inside of the PQR triangle and doesn't really seem to be related to the SQR triangle. So to identify the angles that are less than angle 1, you need to look at the remote interior angles. So you're going to skip over the adjacent angle, and then you're going to look at the corners, so Q and R. Okay, so Q is comprised of two angles, 3 and 4. So if you would add those two angles together, you'd get the big angle Q, angle PQR, so to speak. And then R, if you were to add those 5 and 6 together, you would get angle QRP or PRQ, however you want to read it. So therefore, angle 1 is greater than angles 3 and 4 and angles 5 and 6. And angle 8 is going to be less than angle 1. And then, is it less than angle 2? Because that's the other exterior angle. Yes, it's going to be less than angle 2 because RQ is a side of PRQ. So RQ, this ray being extended, is an extension of side RQ. So therefore, angle 2 is an exterior angle of angle 8. So angle 8 is a remote interior angle, and angles 5 and 6 would be a remote interior angle of angle 2, because it's skipping over the adjacent angle, which is the sum of 3 and 4, and then the remote interior angles would be 8 and 5 and 6. So I hope that makes sense there. So once again, here's everything written down. If you weren't following what I'm saying, you can pause it here for a moment. The next part of this video is not really related to the exterior angle theorem. So the next part of this video isn't going to deal with the exterior angle theorem or inequality anymore. We're going to talk about this angle side relationships in triangles. So basically what it says is, if you know the sides of the triangle, then you kind of know the orders of the angles in the triangle. And this kind of is a precursor to trigonometry, because trigonometry uses the ratio of the sides to figure out the angles that are inside the triangles, and then vice versa. You can use the angles inside the triangles to figure out the side lengths of it. So what this relationship states is that basically the longer the side you have in the triangle, the bigger the angle will be that is across from it or opposite of it. And so how do you know what angle is opposite of the side? You should be able to draw a line from it. So I should be able to draw a line from Z straight across to the side XY. So XY is opposite of Z, and so this X is opposite of angle, side YZ, okay? And so once you get the whole identifying the opposite side and the corresponding angles with it or whatever, then you can kind of, it's easier to understand this property. So in this example here, it's saying since 9 is bigger than 7, the angle that's opposite of angle 9, angle Z, will be greater than angle X because that's opposite of 7, which is a smaller side. All right. So you can kind of order these angles based on the sides that are opposite of them. And then you can do it vice versa. Like angle J is bigger than angle K, so the side opposite of angle J will be longer than the side opposite of angle K. So I took this screen grab from the book. It's basically just restating everything I just said. The largest angle will be opposite of the longest side. The smallest angle will be opposite of the shortest side. The medium angle will be opposite of the medium side. So you get the picture, I hope. So in these examples here, I'm going to list the angles and sides in order from smallest to largest. So if I'm given the side lengths, I'm going to label the angles from smallest to largest. And if I'm given the angles, I'm going to list the side lengths in order from smallest to largest. So here in example 1, I said angle T was the smallest, R was the medium, S was the largest. Because T is, again, you should be able to draw an angle from the angle to the side or the side to the angle, however you want to do it. But I like to draw from the angle. So angle T is across from 23.7, which is, looking at these three side lengths, the smallest side length. All right. So then the next biggest one would be angle R, that is across or opposite from the 35, which is the next biggest one. And then 48 is the longest side. That's going to be across from angle S or opposite of angle S. So that's how I got TRS. In example 2, 25 degrees is the smallest angle, so I can draw a line from the 25 degrees to this side. That side is CD. 35 is the next biggest angle, so I can draw a line across from it, and so the side DE is opposite of the 35, making it the middle angle, or the middle side, sorry. And then 120 is the largest angle, so draw a line opposite of it, and that's going to be side CE. So I'll do a few more examples, but once you get the hang of it, it's pretty simple. Looking at these numbers, 3.8 is the smallest number, so go across from it. That's going to be angle C. All right, 4 is the next smallest number. Go across from it. That's angle B. 4.3 is the next number in line. Go across from it. That's angle A. So this one, we were given 56 and 58, so I just needed to figure out what angle Y was. You know that the sum of the angles in a triangle add up to 180 degrees. So just subtract those from 180, and then I got 66. So that's how I knew what angle Y was. And then 66 is the largest angle, and 56 would be the smallest. 58 would be in the middle. So the angle opposite of 56 is YZ. The side. The side opposite of 58 is XY, and the side opposite of 66 is XZ. So that's how I got these three answers right there. And I just realized I did my numbering wrong. You could tell that the first three examples had 1, 2, 3, and this says 7. My bad. It's not a big deal or anything, but I just wanted to point it out for all the observant people out there. Alright, so here's triangle SUT, and the angles go in order SUT. 5 is opposite of S, so that makes S the smallest angle. And then 11's next in line, so that's going to be opposite of angle U. And 14's last in line, and that's opposite of angle T. So example 9 was a lot like example 7, and it actually has the missing angle is actually coincidentally the same measure of 66 degrees. But yeah, if you're given two angles, just minus them out from 180 to figure out the third angle, and then just put them in order. 54 is the smallest, 60 is the medium, 66 is the largest. So 54, draw a line from it. Opposite of 54 is SR. Draw a line from 60. Opposite of that is RT. Draw a line from 66. Opposite of that is ST. So that's it. Thank you for watching these notes. I hope you learned something, and goodbye.